In Season 7 of The Secret of Skinwalker Ranch, investigators return to one of the most stubborn questions on the property with a new sense of precision. Deep inside the Mesa, in a zone already associated with drilling resistance, signal loss, and repeated measurement anomalies, Erik Bard isolated a compact subsurface target that stood apart from everything around it. It was smaller than the broad underground disturbances the team had tracked before, denser than the surrounding rock, and far more sharply defined than a natural fracture or cavity would normally appear. What drew immediate attention was not a rumor or a story, but a pattern. Independent instruments, used at different times and from different angles, were all pointing back to the same place. That alone made the discovery difficult to dismiss. The Mesa had produced ambiguous results before, reflections that could be explained as voids, mineral changes, broken layers, or equipment noise. This was different. Bard's review suggested a bounded target with physical presence, sitting at a depth and orientation that did not match the expected structure of the hillside. More puzzling still, the anomaly seemed to combine two features that did not belong easily together. It behaved as though something solid was there, yet it did not produce the kind of magnetic response many investigators would expect from a buried metallic object. For the team, that contradiction became the first real clue. If the target was neither ordinary rock nor conventional debris, then what exactly had been sealed inside the Mesa? Before anyone considered drilling, Bard went back through the record. He laid older radar passes against newer terrain maps, compared drone-based surface models with archived subsurface interpretations, and reviewed logs from previous field operations in the same section of the Mesa. Across separate surveys, the same compact reflector remained in place. The surrounding formations shifted slightly, depending on equipment, depth assumptions, and scan angle. This one did not. It appeared again and again, not as a broad blur, but as a contained signal with edges that seemed improbably neat for the local geology. That consistency mattered. False positives often fade when methods change. A shallow fault can masquerade as depth. Layered rock can distort returns. Even moisture content can alter what instruments appear to see. Yet this anomaly persisted through variation. It also sat near a part of the Mesa that had frustrated earlier attempts to understand what was happening inside. Previous operations had recorded unusual resistance in nearby drilling, intermittent failures of communication gear, and moments when instruments produced unstable readings for no obvious reason. At the time, those events had seemed related only by location. Bard's data review raised the possibility that they may have shared a common cause. Even so, the team was careful not to rush to a conclusion. A dense mineral inclusion could produce an unusual return. So could buried industrial debris from an earlier era of surveying or extraction. There was also the possibility of a cavity containing foreign material, which might explain the mismatch between density and magnetic response. Bard's role in the investigation was not to force a theory, but to narrow the unknown. By the time he finished reprocessing the data, one conclusion seemed unavoidable. Whatever occupied that point inside the Mesa, it deserved to be tested in the present, not merely studied in retrospect. A fresh field survey was organized around the target zone. This time the objective was not general mapping, but verification. Instruments were calibrated against a control area elsewhere on the Mesa, and the team worked the marked position from multiple approaches, checking whether the old anomaly would appear under current conditions. It did. The signal returned in real time, and with it came a second feature Bard had begun to suspect. The target did not seem embedded in continuous stone. The new model suggested a subtle discontinuity around it, as though a compact object might be sitting near a small void or chamber rather than fused into uniform rock. That possibility complicated everything. A cavity could help explain the clarity of the readings, but it also introduced new questions. Was the hollow space natural, created by long-term erosion or fracture? Had it formed around the object, or had the object entered an existing void? During the survey window, another variable emerged. Radio quality briefly degraded near the marked location. The interruptions were short, irregular, and not strong enough to claim a direct cause. Yet the control area showed nothing similar. In a documentary investigation, results like these do not prove a mystery. They simply remove ordinary explanations one by one. Engineers reviewing the field data noted that cavity and object combinations can produce complex returns, especially when a dense surface sits against open space. That assessment was useful, but incomplete. It could account for the structure of the measurements without identifying the target itself. The team now had two linked unknowns, something compact, and what appeared to be a chamber beside it. If both were real, then remote sensing had taken the investigation as far as it could go. The next step would require physical access. The drilling plan was deliberately conservative. Bard's depth estimates were combined with structural considerations for the Mesa face, and a narrow borehole was chosen instead of a broader mechanical intrusion. This was not only safer, it also reduced the risk of destroying the very evidence the team hoped to examine. As drilling began, the initial sections behaved much as expected for the local material. Then the pattern changed. Torque readings rose and fell in bands that did not match the anticipated sequence of sandstone and compacted layers. One interval in particular proved markedly harder than the rock immediately above and below it. That hard band drew attention, but it was the cuttings that kept everyone focused. Mixed in with the expected dust and fractured sediment were tiny metallic-looking spherules and altered fragments that seemed out of place in the surrounding geology. None of it was dramatic enough, on its own, to settle the matter. Drill systems can introduce contaminants, bits wear down, tooling sheds material, yet the timing was difficult to ignore. The unusual particles appeared as the bore approached the target interval, not randomly throughout the operation. Then came the moment that changed the tone of the investigation. At the predicted depth, the drill behavior shifted abruptly, resistance dropped, and the bit appeared to enter open space. The logs suggested the borehole had broken through into a small cavity. That result did not identify the object. It did, however, confirm that the internal model was more than an abstract interpretation. There was, in fact, a discontinuity inside the mesa exactly where Bard's analysis suggested one should be. A cavity raised new possibilities and new cautions. Natural pockets can form in ways that appear strange from a distance. Fracture chambers collapse. Old drilling routes can create misleading voids. The metallic-looking particles might still have a mundane explanation, but the combination of events was becoming harder to treat as coincidence. A repeated anomaly, an unexpected hard layer, altered cuttings, and now open space at target depth. Rather than widen the breach, the team chose a more revealing approach. They sent a borehole camera into the cavity. The first images were limited, grainy, and easy to underestimate. The camera light swept across rough interior surfaces that looked exactly as one might expect: broken stone, uneven walls, dust, and shadow. Then the lens moved slightly, and a different texture appeared. Against the jagged cavity wall was a smooth, reflective surface unlike anything else in view. It did not resemble crumbling rock. It did not scatter light like weathered sandstone. It returned the camera's illumination in a dense, controlled way, as if the beam had found something non-porous and distinctly separate from the chamber around it. In a few frames, the visible surface seemed gently curved. In others, there appeared to be a sharper transition, almost an edge. The team was careful not to overstate what the camera showed. Limited angles create illusions, reflections bloom. Moisture, dust, or lens flare can turn an irregular face into something that looks engineered. Yet material specialists reviewing the imagery agreed on one basic point. The visible target surface behaved differently from the natural walls around it. That was an observation, not an explanation. Still, it was enough to deepen the central mystery. If the camera was not seeing an object, then it was seeing a geological feature unlike any ordinary surface expected inside that section of the mesa. There was one more detail, visible only briefly, that lingered over the rest of the investigation. Across part of the reflective area, faint linear marks appeared under the borehole light. They might have been grooves. They might have been shallow fractures. They might have been nothing more than optical artifacts produced by a poor angle. But because they were never visible long enough to classify with confidence, they became a classic open question, too weak to prove anything, too suggestive to ignore. At that stage, the investigation slowed down for a reason. A documentary earns trust by knowing when not to leap. Samples from the drill interval were sent for laboratory review, and the results brought clarity only in part. Under microscopy, some fragments showed altered textures inconsistent with undisturbed surrounding strata. Trace metallic spheres and fused particulates were present, but in low quantities. The findings suggested that unusual conditions had existed near the target zone. They did not identify the larger object seen on camera. Geologists reviewing the samples pointed out that heat, pressure, and chemical change can all alter rock in localized environments. Metallurgists noted that small recovered particles can be profoundly misleading when no direct sample of the main target has been obtained. A cave wall touched by mineral-rich fluids can produce surfaces that seem unnatural. So can impact-related alteration. So can industrial contamination from earlier activity. Every plausible explanation remained incomplete. The lab could confirm that the target environment was not ordinary. It could not yet say why. That uncertainty became especially important because the object still lacked one of the signals many observers would expect. If the reflective surface was metallic, why was there no strong conventional magnetic profile? One answer was that the visible area might represent only a surface layer. Another was that the material was unusual, composite, or shielded by its surrounding conditions. A simpler possibility also remained: the object might not be metal at all, but a rare geological formation with properties that only appeared to mimic an engineered surface. In a credible investigation, such alternatives are not obstacles. They are the framework that keeps speculation from outrunning evidence. With the laboratory work unable to close the case, the inquiry widened. Historical records tied to the mesa were reviewed again, this time with Bard's coordinates in mind. Survey notes, contractor logs, property references, and old engineering sketches did not provide a dramatic revelation. What they offered was subtler and in some ways more intriguing. Across different decades, there were hints of trouble in nearly the same portion of the mesa, references to unusually hard drilling intervals, notes about equipment behaving unpredictably, and one older notation suggesting a hard stop that did not align with expected strata. No document stated plainly that an object had been found or placed there. That absence mattered. It meant there was no simple hidden file waiting to solve the mystery. Yet the overlap in location was difficult to ignore. A site that had troubled modern investigators appeared, at least indirectly, to have troubled earlier crews as well. Local recollections added still more texture. Several accounts described machinery acting oddly near the mesa years before the current investigation, though memory is never equivalent to proof. In this case, the testimony served only one purpose. It suggested that the problem may have a deeper history than the present team first assumed. By then, the investigation had crossed a threshold. The question was no longer whether something unusual might be there. It was whether the anomaly could be shown to do more than occupy space. Bard proposed a controlled signal experiment. The idea was modest but important. Introduce a low-power swept signal near the target zone, compare the returns to a matched control setup elsewhere on the Mesa, and watch for repeatable differences. If the target merely reflected energy, like an oddly shaped cavity wall, that might be visible. If it responded in a more complex way, that too might emerge. The results were not theatrical. They were measured, technical, and all the more compelling for that reason. Near the target borehole, the return pattern included a delayed repeating signature that did not appear in the control test. The anomaly was not constant. It did not produce an endless effect. Under specific frequencies and alignments, however, something in the target zone seemed to alter the signal path in a consistent way. Seismic monitoring added another layer. The object appeared more likely to be sitting within a bounded cavity than embedded firmly inside continuous rock. Radio engineers and geophysicists reviewing the data offered competing interpretations. One group argued that the repeating return could be explained by cavity geometry alone, especially if the chamber had unusual proportions. Another suggested that a dense surface within that cavity might be introducing its own reflective or resonant behavior. Neither explanation was fully satisfying. The strongest point of agreement was narrower. The test had produced an effect specific to the target zone, and that effect was not easily reproduced in the control setting. If the object was influencing measurements under certain conditions, then understanding its shape became even more important. A second narrow-access approach was planned, not to extract the object, but to view it from another angle. This was the most delicate stage of the investigation. Too much intrusion could damage the cavity or contaminate the evidence. Too little, and the team would remain trapped in the ambiguity of the first camera footage. The second access route was aligned carefully to intersect the chamber at a different orientation. What the camera revealed this time was not a dramatic unveiling, but it was enough to change the balance of the evidence. The reflective surface no longer appeared as an isolated curve alone. From the new angle, part of it transitioned into something flatter, with a more coherent boundary against the surrounding space. It was still only a partial view. Most of the target remained hidden, yet the geometry now looked harder to reconcile with a random mineral face. Scale estimates suggested that the visible portion represented only a fraction of the whole, implying that the object extended beyond the cavity wall into surrounding material or deeper into the mesa. Residue collected near the second bore interface added one more clue, though an incomplete one. Analysts found indications consistent with a layered or coated material, but not in sufficient quantity to define composition conclusively. Imaging specialists, materials experts, and drilling engineers disagreed on the larger interpretation. Some believed the emerging shape strongly suggested an engineered object, or at least a coherent foreign body. Others warned that rare geological processes can create deceptive symmetry. That disagreement was important because it preserved the investigation's realism. Stronger evidence had been obtained. Final certainty had not. By this point, one earlier question returned with greater force than before. If the object had definable geometry, how did it come to be inside the mesa? A natural inclusion was still possible, but less persuasive than it had been at the beginning. A remnant of industrial activity remained plausible in theory, yet no record had identified a buried device, casing, or abandoned equipment in that location. The possibility of intentional placement could not be ruled out, but neither could it be defended with evidence. The most honest conclusion was also the most unsettling. The team had documented a real, bounded, physically distinct unknown inside the mesa, and its origin remained unresolved. That, in itself, was a major shift. At the start of the investigation, Bard was evaluating an anomaly in the data. By the end, the team had assembled several converging lines of evidence. The target had been mapped repeatedly. A borehole had reached an internal cavity where predicted. The camera had captured a smooth, reflective surface inconsistent with the chamber walls. Controlled testing had produced a specific and repeatable signal behavior not matched by a control location. A second viewing angle had strengthened the case that the target possessed physical boundaries and coherent form. And yet the mystery had not narrowed into a single answer. The most credible working theories remained several. The object could be a rare geological body with extraordinary properties. It could be the remnant of earlier human activity not preserved in available records. It could represent a layered material or structure unlike anything the surrounding strata should naturally contain. Each theory explained part of the evidence. None explained all of it. That is where the investigation found its deepest tension. The team had uncovered enough to move beyond speculation, but not enough to claim understanding. Extraction might reveal the truth, yet it could also destroy context that only a careful, non-invasive study can preserve. Expanded imaging might show more, though the object's position inside the mesa would continue to limit access. Preservation would protect the site, but leave the largest questions suspended. In the end, the most significant result was not simply that something had been found. It was that a persistent anomaly inside the mesa had become a documented physical target, visible in part, measurable under controlled conditions, and still resistant to ordinary explanation. For Erik Bard, that meant the investigation had crossed from uncertainty into evidence. For everyone else, it meant the central question had changed. No longer was the mystery whether the mesa contained something unusual. The mystery was what kind of object could remain hidden there, influence the data around it, and still refuse, even after all that had been uncovered, to fully declare what it was.